Hey everybody, I hope y'all are doing good. I'm going to take a few minutes and talk about our Millermatic 252 that we'll be using in class. I know some of you have probably sat through classroom time where we talked about it. You've actually been out in the shop and welded with it. But I'm going to go over it in a little bit more detail and show you some things that we probably didn't cover while we were out here in the shop. Okay, so the main thing to understand, this is a completely self-contained gas metal arc welding machine. It has got the power supply, it's got the wire feeder, gas controls, everything is all built into one unit. This is a constant voltage only power supply. So when I say that, you should know semi-automatic processes, gas metal arc welding, flux core arc welding, something that can continuously feed your wire. This machine will not stick weld. The wire feeder mechanism is on the inside. We're going to talk about that a little bit in a minute. The controls are on the outside. Constant voltage power supply. We adjust the voltage over here on the left. We adjust the wire feed speed on the right. Wire feed speed, you should know, as you increase wire feed speed with a given voltage, the amperage goes up. Decrease the wire feed speed, the amperage goes down. Inside the machine there is a chart for some of the settings that you should use. Okay, these are ballpark settings, but this is a pretty useful little chart. It lists over here on the left the wire type. It's got solid 70S6, shielding gas 7525. It's got different diameters based on the base metal thickness. You can select those. It shows a breakdown for the torch or the gun consumables right here, part numbers and everything else. It also tells us on the inside how to use the timers menu and other settings that are on the machine. Okay, and I'm going to go through some of those real quick. The component that you're going to mainly be working with, besides adjusting the machine, is going to be the gun. Okay, the gun consists of a gas nozzle, a contact tip. In this case, these contact tips screw in and out, and they are specific for the size of wire that we'll be using. We'll be using 035 ER 70S6 for the most part. Okay, so we'll be using an 035 contact tip. The part that's behind the contact tip right here, it's got some very small holes in it. It's called the gas diffuser. This is the place where the gas comes from the gas supply through the machine, through a gas solenoid that cycles when you pull the trigger, and it comes out right here. Comes on the inside of the nozzle and comes out. These nozzles fit on here by friction for this gun, so there's a little ring here with some dimples in it. I can just slip it on here, fasten it down. Other guns may have to screw on, may have to tighten up another way, but that's how this one works. Things about the gun that we should be aware of: the liner that's in here that the wire actually passes through is a tightly coiled spring of wire, pretty tight. If you wrap this around these posts right here and you pull it tight, you're going to bend that conduit on the inside. And if you'll look right here, right about there, there's a slight kink. I can feel it with my hand. This $40 liner, $50 liner has been pulled too tight by somebody, and they pretty much made it where the machine will not feed wire well. If you wrap this gun back up on here, do not pull it tight. Eventually, your old welding instructor is going to cut those hooks off of there and eliminate that likelihood just a little bit more. I'm going to turn the machine on with the trigger pulled. Then you'll notice it says run 100. That's what's called the run-in speed. That's the speed that the wire will come out when I first pull the trigger, and until it makes contact, it will come out at that speed. I can adjust other settings on this machine, including pre-flow. Okay, it says pre right here. That's the amount of time the shielding gas flows before the wire begins to move and electrical contact is made. Gets a little bit of shielding gas out there before you start welding to help protect your weld node. Turn it again. It says POS. That's post-flow. When I let go of the trigger, the gas will continue to flow for a little while after the wire has stopped moving and the electrical current has been shut off. Next one, this is BUR. That's burn back. When I do let go of the trigger, after the post-flow runs, the voltage will stay, but the wire feed will quit moving. That will allow the wire to burn back a little bit and get out of the puddle. This can be helpful in machine operations and robotics, stuff like that. The next one says SPO. That's a spot timer. If I turn that on, then that's going to make a spot weld for 1.3 seconds, no matter how long I hold the trigger. Okay? So you're typically going to want that off, because if you have it set on anything, it's going to mess up and confuse somebody, and they're going to wonder why their machine only welds for so many seconds and then it cuts off. Please don't do that, even though it's kind of fun, I ain't going to lie. We're going to put that back to 0. And that's about it for the settings that will come up by default. Now there's a couple of other sequences you can go through with the trigger and see some other things, but that's all we're going to cover for the most part as far as what the trigger does. So you see over here on the left my voltage, wire feed speed. Again, I can select those. So one of the common settings that you will start off on in class if you're in the first semester is about 17.5 and 235. 17.5. 235, a little bit one way or the other, ain't no big deal. So see where that puts us at, approximately. That's over here for 1/8 inch thick material with 035 wire. It lists 17.4 and 230. I do 17.5, 235. You can play up and down with those some. So that kind of covers the controls on the machine, the gun. Please be aware of pulling that lead too tight to put a kink in it. Okay, it makes it very hard for us to weld during the day. Don't do it. And we'll go ahead and talk about the wire feeder here in just a second. Now we're going to go ahead and talk a little bit about the wire feeder. Okay, again, it's built into the machine. It consists of a couple of different components. It's got a spindle that your roll of wire will mount on. A couple of different sizes of spools you can put on there. This one, I believe, was about 33-pound spool to begin with. They make little small ones. Okay, there are 44-pound ones. They are retained on here with this ring. The spindle has a clutch in it that will keep it from spinning too free. The pressure on that clutch is right here. One of the reasons that's important, if you're welding with a high wire feed speed range and you let go of the trigger, the momentum in the spool will cause the wire to do this. Then the wire will come out here like that, and next thing you know, you've got a terrible, terrible mess. Okay, now typically they're going to already be set for you. If I loosen it up too much, the spindle turns a little bit too easy. I'm going to tighten her back down like it was. But that's one of the components of this. For this component to work, there's a small pin that sticks out of the back of the spindle back there, and it has to mount inside your roll. This one is a wire roll. It's going to hit it sooner or later and stop. On the fiber rolls, you'll have a small hole in there that you'll have to stick that pin through. You just have to slide it over the top of it. Here's where we would select our polarity. You notice there's a red and a black. The red is typically going to be your positive terminal. The black is going to be your negative terminal. For welding with gas metal arc welding with solid wire, almost always electrode positive, DC reverse polarity. Now if we were going to use flux core wire that was self-shielded and of the classification E71T11 for instance, then we would have to swap the polarity. We would do that by turning the machine off, loosening both of those nuts up, and swapping those leads around. That's shown up here. The drive rolls. The drive rolls. The drive rolls are different types depending on the wire type. I've got a pair of flux core drive rolls right here. These have got little ridges in them that will help grip the wire better. The reason that's necessary is with flux core wire, it's hollow. If I put too much pressure squeezing it together, it's going to crush the wire and make it out of round, which is going to make it difficult to feed. Most of what we're going to be doing, especially if you're in a first semester class, is going to be gas metal arc welding with solid wire. Drive rolls are right here. For me to remove the drive rolls, I can turn that knob, pull this down right here, and slide that drive roll off. This drive roll is marked 035V on one side, V is the type of groove, 035 is the diameter, and 030V on the other. I'm using 035 wire, so when I put it back, I want the 035V portion facing out towards me as I read it. Okay. If you open this up and take a look at it, you'll actually be able to see the liner I was talking about earlier. It actually extends through part of this. And I'll maybe get a picture of it, put it in the video. But right now we'll just go on. When I close my drive rolls, all I got to do is push this back up again. The amount of pressure that's on the drive rolls is adjusted right here. Okay, more is not always better. You want it to be where the wire will feed out of the gun without stopping. Let's just say I put it off of the concrete floor about that far. It should spin up and make a coil. Now this one won't do it because of that dent or that kink that's in the liner. Okay, it makes it a little bit more difficult. If I loosen it up too much, drive roll spin won't push the wire. Tighten it up too much, it will begin to flake some of the copper off the wire. Puts a little bit of a strain on the drive roll motors. Okay, so that kind of covers it for the machine. For the wire feed portion of it, some of the adjustments you can do. Whenever you come up to it and get ready to work, make sure the work lead is attached and in good condition. Make sure the gun's in good condition. Make sure your booth's free of any kind of fire hazards, that kind of stuff. And of course, make sure you have shielding gas, and we'll talk about the shielding gas maybe in another video. But make sure that you understand how to verify that it's the proper gas, and also how to set the flow rate. Have a good day.